With addition and subtraction, we have to take into account the fact that many of these numbers that we're going to add and subtract have different numbers after the decimal point. So remember that with multiplying and dividing, you look at the whole number and you use the number with the fewest total number of significant figures in your final answer. Okay, addition subtraction is a little bit different. Okay, when you add or subtract, your final answer must have the same number of digits to the right of the decimal point as the number with the fewest digits to the right of the decimal point. Okay, so rather than look at the whole number, you just look at how many numbers come after the decimal point. Whichever one, again, has the fewest, that's how many go in your answer as well. So in example 1 here, look at 12.11. It has 2 digits after the decimal point. And it doesn't even matter if they're significant or not. Okay, in this case, they all are. So 12.11 has 2, 18.0 only has 1 after the decimal point, 1.013 has 3, and 31.123 also has 3. Okay, so when we add those all together, we're going to get a number of, or sorry, no, that's not correct, sorry. Those are the 3 numbers that we're adding together. You add them together, the calculator says the answer is 31.123. Okay, but because the number 18.0 only has 1 significant figure, or sorry, only has 1 digit after the decimal point, it doesn't matter again if it's significant or not, then our final answer also can only have 1 digit after the decimal point. So the final answer is 31.1. Now, it's just coincidence that 18 also has 3, and so does the final answer. But again, many times with addition and subtraction, your final answer will not have the same total number of significant figures like the multiplication and division rule. Okay, in example 2, we've got the number 21, and we're subtracting 13.8. Calculator answer is 7.2. But because the number 21 has no digits after the decimal point, then your answer can't have any digits after the decimal point. So the correct answer is just 7. Okay, here's some examples of that. Let's look at some of these. Again, at this point, go ahead and pause it. You always want to get your calculator answer first and then round it based on the significant figure rule. So give these 10 here a try, and then we will go over them together here once we come back. Okay, so 13.25 plus 2.6. Again, calculator answer is 15.85, but because 2.6 only has 1 digit after the decimal point, I have to round that to 15.9. Okay, after the 8, the next number is 5 or greater, so I've got to round that up. Okay, on letter B, 0.00156 plus 0.0050 equals, again, calculator-wise, 0.00656. Okay, this has 5 after the decimal point. Again, doesn't matter if they're significant or not. This has 4 after the decimal point, so my answer can only have 4. So therefore, my final answer is 006. And then the next number is the 5. That's my last digit is the 5, but the number after that is greater than 5, so I've got to round that up to 0.0066. Okay, letter C, 62.5 plus 13 is 75.5. Again, 13 has nothing after the decimal point though, so our answer can't either. So 75.5 rounds up to 76. Okay, letter D, 91.0050 plus 63.00000, bunch of zeros. Okay, this has 4 after the decimal point. This has 4 after the decimal point. Our calculator answer only gives us 3 after the decimal point. The calculator answer is 154.005. But again, we have to follow the rule that they both have 4 after the decimal point, so our answer has to have 4. So what do? We throw a 0 on the end. Okay, letter E, very similar. 2.50 plus 7.50 equals 10 on the calculator. Okay, but both of them have 2 digits after the decimal point, so we have to as well. So it's got to be 10.00. Okay, letter F, 76.18 minus 95.0 is a negative number, obviously. Negative 18.82. Okay, and 95 only has one digit after the decimal point, so we also can only have one digit after the decimal point. So negative 18.8 would be our final answer. Okay, negative 0.00153 minus a negative 0.568 is 0.56647. Okay, however, 0.568 only has three digits after the decimal point, so our final answer can only have 3 after the decimal point. The number after the 6 is less than 5, so we keep it as 0.566. Okay, letter H, 1.25 minus 0.25 is 1. Okay, but both numbers have 2 digits after the decimal point, so we can't just put 1. It's got to be 1.00. Okay, 125.2 plus 74.8 equals 200. And again, both of these numbers have one digit after the decimal point, so we also have to put our one digit after the decimal point, 200.0. Okay, and then the last one, 0.0065 minus 0.0015 equals 0.005 on the calculator, but this has 4, this has 4, so again we've got to put a 0 right there, so we have 4 after the decimal point. Okay, and the only other thing I'm going to mention here, hopefully that is pretty clear, the only thing I'm going to mention here is what if you have a problem like this? What if you have like 74.2 minus 68.1 over let's make it even easier than this. Let's say you have 25.0 minus 22.0 over 11.0. I'm going to change it just a little bit here. 25.0 minus 3.0 over 11.0. This is a problem where you have subtraction, but you also have division. So what do you do in this case? Okay, because you've got two different rules for significant figures. Do I just look at this and go, well, this only has 2, so my answer can only have 2? Or do I look at it as they all have one digit after the decimal point, so my answer has to have one digit after the decimal point? Okay, the way that you solve a problem like this is, well, before I divide by 11, I have to subtract that 3. So the first thing I'm going to do is I'm going to subtract. Okay, so forget about this 11.0 on the bottom. Forget about that for right now. Okay, all we're going to do is use the subtraction rule, and we're going to go 25.0 minus 3.0. Well, using the subtraction rule, they both have one digit after the decimal point, so we have to have one digit after the decimal point. So it's 22.0. Okay, and now that we've subtracted and we've applied that rule, now we're going to switch rules, and now we're going to go to the division rule, which means this has 3 digits, this has 3 digits. My answer, therefore, must have a total of 3 digits. So calculator-wise, it's equal to 2, but I have to have 3 digits. So it's got to be 2.00 is the final answer. So when you have a problem that involves multiplication or division and addition or subtraction, you have to apply, when you're about to switch rules, you have to apply that rule. So here we apply the subtraction rule to get that number, and then we apply the division rule to get our final answer.